So we want to make a sketch of the system. And to do that, we need all the information from the text. So we start by sketching the box that we know that we are going to need. So I draw a box here. This is the dryer. And we know that something comes in to the dryer and something comes out. So we read up here. In a continuous process, every hour, 1,000 kilos of wet feed. So M in equals 1,000 kilos. Okay, it has got a water content, not dry matter, but water content. So moist equals 45%. We know that 45% moisture equals 55% dry matter. So we make that calculation instantly. It is dried with warm air to a water content of 5%. So we know that moist over here, moist out equals 5%, giving us, I just have to erase that, giving us 95% dry matter. M out is probably something that we are going to find, so we don't know that one yet. So that was the 5% here. Then we go a bit further. The wet product has a temperature of 60 degrees when it enters, and when it leaves, it has the same temperature. Same temperature here. So T out is 60 degrees centigrade, which means that the air out here, air out is also 60 degrees. We know that there will be some kind of heating thing in the instrument here, so we will draw that one. The air is taken from production room with a temperature of 25 degrees. So cold air enters here. So Tn is 25 degrees centigrade with a relative humidity of 40%. So that was that one. The drying air is heated to 120 degrees. So T heat equals 120 degrees centigrade. So that is the temperature that enters the drying chamber. Then we get the information that the heating apparatus here is heated with steam at a pressure of 2.5 bars. So pressure 2.5 bars. The steam is condensed and leaves the heat exchanger through a steam trap. So we draw a steam trap here. This is a condenser. So we get condensed steam out here. So this is basically a drawing of the entire process. We need, in order to make further calculations, we also need a table of all the values that we are going to use for the further calculations. So if we make a table here where the condition for air in, the conditions for heated air, and for conditions for out. So up here, this is the air in the system. So we know that we have several values that we want to look at. So for the temperature, we can read that off here. That was 25 degrees. So in degrees centigrade. It is heated to 120. It leaves at 60. We also know that the relative humidity when the air enters are 40%. And in the molecular diagram, we can calculate the rest. We can also, from the molecular diagram, read the absolute water content in the air and the enthalpy of the air and the wet temperature. So now I just need to make this table a little bit larger here. So wet temperature centigrade, the enthalpy is in kilojoules per kilo of air. The absolute moisture is grams water per kilo of air. Humidity is in percentage. So all the cells here in the table that are not filled can be calculated from the molecular diagram, which I will show in the next video.